All right, everyone. Welcome to week 8, day 3. Halfway through the semester, we are going to continue our exploration of data structures today. Let me turn the lights on. Give me 1 second. All right, that's better. It's kind of backlit there. So we're going to continue learning about data structures today. First of all, do you guys have any questions about the homework? How the map works? A big part of computer science is being able to look at source code and kind of figure out at least a little bit what it's doing and modify it. For example, turn off incurses, turns off full screen mode. Turn on incurses, turns on full screen mode. What do I mean by full screen mode? You know, like when you're in Vim, it's full screened and you can like type things and they immediately appear. That's different from normal CN and cout. Normal CN and cout, nothing happens until you hit enter. The raw mode, which is enabled by this function here, that will allow you to get arrow key as input, things like that. And so incurses has a function called get character, and it will allow you to read things like F keys and arrow keys and things like that. We have a question on how we would save the state of the map. Okay, go for it. And so if they hit the right arrow key, then your X location increases. If you hit the edge of the map, then it will stop you from going off. So what you're going to need to do is add in here some code that will stop you from walking over a wall or possibly a water. If no keystroke is entered by the user, which is what happens 99% of the time, then get returns error, which just means no keystroke was read. It's not a big deal. It's not really an error. It just means nothing was read. You can have a semicolon by yourself. That just means do nothing. If I deleted this, it would be exactly the same. I'll do this sometimes just to indicate that I'm intentionally not doing anything. So it's not like I forgot to, put in code here, right? I'll note that if nothing was typed in, do nothing. If you press and hold, will it record movement like in video games, or do you have to press for each movement? Yeah, depends on your terminal settings, but yeah. I'm holding down up arrow, should work. If the location changes, then it clears the screen and redraws it. I think technically we could probably get away with not clearing it. You might want to try commenting that out and see if that works. So it should be redrawing the same area every time. So yeah, less flickering that way. Whereas if we have the clear in there, it clears the screen, then it redraws it, and it I see a little bit of flickering. Yeah, I would probably just take that out. It's in there just as a safety measure. Oh yeah, probably these would probably break, huh? No, that should work. Okay. Cool. Incurses programming how-to. Yeah, that's Mui and I have spent a long time on that website right there. Incurses is build in C++. What does that mean? How to adjust the size of the map? Or is what the question? So incurses is a C library to answer the question. it's not in C++. Just make sure that you guys use make to build the thing instead of G++ or compile. Make will invoke the make file, and that will link in the libraries that you need. It will link in the curl library, and it will link in the incurses library. If you don't have that, it won't work. Alternatively to using the incurses library, you could use my colors.h. Colors.h also allows you to do immediate mode, supports mouse support. My colors library also supports 24-bit color, which incurses does not, because reasons. The author doesn't like 24-bit color, more or less. As long as there's no standard on it, he won't support it. Would our bridges circular linked list update over every turn? No, I would only do it once. First time you do combat, just visualize it. That's all you have to do. The first combat. When you get into combat, you know, you should have a number of heroes, you should have a number of monsters. It should create a circular linked list with all the heroes and monsters merged together in sorted order, and then visualize it. Or maybe have an option when you're in the combat screen to hit a button and it visualizes it on bridges. I wouldn't do it every time. What if somebody were to die? Delete them out of the list and revisualize? You could, or not. I would just do it at the combat start, honestly. There's an issue with bridges where bridges doesn't always work if you try visualizing it twice within the same program. So I would just do it once. No. Or let the user control it. The size of the map could be 100 char by 100 char, yeah. Yep. Absolutely. Be whatever you want. I gave you guys a little sample map class that does some random generation stuff. 5% chance of a monster, 3% chance of a treasure, 10% chance of a wall, etc., etc. Yep. So you don't have to use this, by the way. You just make your own. So I just wanted to give you guys something to start with. You can make a better map generator, or use Muya's map generator, which is better than my random thing. The way my water generation works, it's kind of clever. It'll randomly roll a 3% chance for water. But if the tile is next to another water tile, then it will have a 20% chance. So it tends to create bodies of water instead of just random tiles filled with water. It will tend to make random pools of water. This. How do we find what keys are linked to their numbers, such as up? You should not need to care about what numbers they are. If you were to be using the number 65 here, that would be meh. I wouldn't do that. There's absolutely no reason to ever use the numbers. Just find out what the names are in incurses. Frame rate setting is tricky. So max FPS is controlling. So if you do that, so did you guys know you can put single apostrophes into numbers? That's a modern C++ thing. Makes it easier to count out the digits and things like that. So that's a million. So that's a million microseconds. A million microseconds is a second. U stands for micro. And so if you have a max FPS of 30, then it's going to sleep for a 30th of a second. And technically what it should do is check the current time and sleep less if you've spent a long time on this frame, but this is really basic. So basically, after you finish a frame, it sleeps for a 30th of a second, and that caps the frame rate at 30 frames a second. Can you see out things when incurses is on? No. Or you can, but it breaks everything. You want to use this function instead. So mv print w is the function you want to use. So mv means move, and so it's going to move to a row and a column. So this means column 0, row, however big the map is. If the map's a 50 tall, then this goes down to row 51, column 0, and then it prints this string at that location. Now this is something called printf. Printf is a little bit different from cout, because ncurses is a C library. It's not a C++ library. So %i means print an integer, and %i means print an integer, and what integers does it print? Follows it in the parameter list. So this is how you cout things in C. This notion here. And so if you need to print out a double, it's F. If you need to print out a string, it's S. If it's an integer, it's an I. That's all you should really print. And so mvprintw is the incursive's way of printing something to the screen. This is row, column. This is the string to print. And if you put any special format characters in here with a %i, then the first %i will be x, because it's the first parameter, and the second one will be the second parameter, which is y. Okay. Can you check the stream quality? Stream quality is set to 4K resolution, 1080p. I will lower the quality for you guys. That should improve the quality, hopefully. Yep. All right. And then refresh redraws the screen. So this draws the map on the screen. That refreshes it. That's an incursive call there. And then that's how you can print things on the screen. Okay. So that turns on incursives, that turns on colors, clears the screen, disables echoing keystrokes to the screen. How long it'll wait for the user to type a key. Okay. So that's it. It's main is only 2 pages right now. But you see we got colors, we got a world map. It's a good starting point. So you guys need to make a hero class, you need to make a monster class, you need to make a circular linked list. Make sure you get a partner. How many people here still need a partner? Go ahead and post on the chat channel, and hopefully you can meet up, hook up with each other, get a partner. All right, so yeah, just arrange it yourselves. It's self sign up for this one. This is example bridges code for making a circular linked list. So yeah. Okay. All right, so we are going to learn some stuff today. Do you guys have any other questions about the homework? How to write a file, ifstream to input things, ofstream to write things to disk. So if you've got a 2D vector, you should know how to print a 2D vector to disk and load it back up again. And then to save the heroes and monsters, what I would do is create an operator double left arrow for the hero class, and an operator double right arrow for the hero class, and double left arrow the hero to file, and then double right arrow the hero back out of the file. Just have them be mirror images of each other, and then that's a pretty easy way of saving and loading. It's by overloading those operators. So those of you that posted on the chat channel, message each other, figure it out. All right. We did a study session yesterday at the Tutorial Center. If you didn't have an opportunity to see it, he will post the link somewhere. And I will link it off the class canvas. Still uploading to YouTube. Okay, that's fair. So you guys have until next week to do the makeup, or the third take on the competency exam. Should be easier than take 2. So. All right. So what should we learn today? So we have learned about vectors. We've learned about stacks. We've learned about queues. We've learned about arrays. Do you guys know the C++ version of an array? Maybe not. So we all know the C version of an array, right? So this is going to make 100 integers, right? 100 integers makes 100 ints, all initialized to 0. Can we ask questions during the weekend? You can always ask questions. I'm on Discord constantly. Okay. Are you guys familiar with this? Hopefully, from CSI 40. Make 100 ints. Cool. Vector of ints. Now you guys know what this means, right? It's a template. So in the vector class, there's a place where it will say t, and then everywhere there's a t in the vector class, int will be filled in. It'll generate a new vector class with t substituted with int. Vector of ints named vec of size 100. So what is the difference between these two things here? You guys remember? CSI 40, we talked about this a bit. What's the difference between a C-style array and a vector? Anyone remember? These two things do the same thing, so that's element 5 to be 42. Vectors, you can also do vector.at. 5 equals 42. Yeah, so vectors don't necessarily have to bounce check. If you do this, it won't bounce check necessarily. All right. This will bounce check always. And so I don't like using that version of a vector unless I will use it if I have guaranteed that it is going to be within bounds. But even then, I usually do this first, just to make sure that I didn't screw up somewhere. Yeah, so difference between array and vector. Vectors can bounds check .at. There is no .at for arrays. Vectors can grow, resize. What else? For example, we say vector.pushback, -99. Add -99, 5 times 2 back. All right, whatever, you can grow it. Vectors can be resized. Sort. What do you mean by sort, Bazookian? Got iterators. All right, so yeah, so you can do sort vec.begin to vec.end, sure. All right, so let's fill both of these guys with random data. Okay. So you don't think you can sort an array? You don't think you can do sort array.begin to array.end? What do you think? You can actually. The array data type, the array type does not have a member function on it because it's not. Look, you can see what it's saying there. It's not a struct, right? The array is not a class. It doesn't have member functions on it. However, a array is actually an iterator. So you can actually do that. That works. It is using the sort function. Yeah, sort takes 2 pointers, takes 2 iterators, and a pointer is actually an iterator. So that's one of the reasons why I use them interchangeably, because I want you thinking about iterators as pointers, even though technically they're not. An iterator is just a class that behaves like a pointer. The standard library is actually designed so you can use a pointer. An array is a pointer, more or less, and it's just a memory address. It's literally just an int. It's the memory address of the start of this block of memory, and you can actually pass it to sort, and this will sort from the beginning to the end. Yep. So, algorithm is included. Let us make a random. Let's fill it with random numbers. How can we fill a vector with a bunch of random numbers? What do you guys think? It's a good way of doing that. For loop and rand. Good. What random numbers do? Just rand? Just any result around? Okay. Make it size 10 so we don't spam ourselves. Are you guys familiar with that? Range-based for loop? So vectors can use a range-based for loop, right? Which is nice if you try doing this with array. Okay. Okay, so we will generate a bunch of random numbers in R. Or will we? I don't know. Does this work? we will make a random number generator, int rando return rand modulus 100 plus 1. So make a random number from 1 to 100. Oh, right. Yeah, should not have put the parentheses on that. Okay, doesn't matter, I want to do that anyway. And there we go. Okay, so what did I just do? And why did sort break? And what's going on? And how did range-based for loops work? And why did we crash? There's a lot of stuff that just went on here. Okay, so R is why did we crash? First of all, what happened here? What happened? Yeah, I made a function called rando. If
Kearney, we can't hear you.
Yay, blue microphones, such high quality. All right. So what's going on here is generate. It's so terrible. You wiggle the audio cable and it cuts out. What happens here is that generate is going to call this function over and over again. This will call rand, you know, the standard library function, and it will put the results of rand into array. And what's interesting is you can actually do it this way. Even though that you can't do this, you can't do vector.begin, you can actually call begin and end as global functions. And they were written exactly for this reason. So why is my code crashing though? Why is the code crashing? Anyone know why? No, you're out of bounds. All right, so how I originally put it was I used the pointer as the begin, and I used the pointer plus 100, which you can do, that's perfectly valid, as the end. But this is a reason why you should not use magic numbers in your code, ever. Because if you change something here, change something there, I didn't change it down here, right? And so this thing was accessing memory outside of its bounds, and it crashed. So the proper way of doing this is const size t size equals 10. I really don't want to see you guys using magic numbers like this. Always, zero's fine. You do 0. You put 0 in your code, that's fine. Sometimes 1's okay. But if you ever have like a 10 or a 20 or a 100 in your code, it probably shouldn't be there. It should be within a constant. Okay. And so that's exactly why we do that. So I shrank the size of the array so that it wouldn't spam numbers off the top. And then is it sorting the pointers? It is sorting the array, I think. Let's find out what happens when it works right now. Stack smashing detected. Terminated. Such a great error message. All right, so here we go. So array is these numbers here. And then it's, you know, let me go back to rando. Rando makes more human readable numbers. So what does generate do? So generate starts at the beginning of the array, goes to the end of the array, and sets each element of the array essentially to the output of this function, which is a number from 1 to 100. And then we do the same thing for the vector. So we can see that array started off with these numbers here, and then we can sort it, and it properly sorted them. You're like, but wait, I thought you said you can't do a range-based for loop with an array. Well, sort of. The answer is sort of. This works if you are within the scope of the array when it was made. If you tried passing this to a function like void print array and you took in the array that way, you can't use it. Because what happens is if you ever breathe on an array, if you ever sneeze on an array, it decays into what's called, it does what's called pointer decay. It turns into a pointer. And you can't do a range-based for loop with a pointer, right? It would, however, work if you did print, like if you tried doing this, you know what I mean? Like format x, an array, step x. This code would not work. So even though you could print the array this way, do you guys see that? The range-based for loop works here. If you were to pass the array to a function, it would not work. And the reason for that is because arrays immediately decay into pointers, and it's a really dumb system. It's a really stupid system. Can you explain? I don't understand pointer decay. So here we have an array. But if we pass the array to a function, print array, passing an r, if we pass the array to a function, the array turns into just a pointer. It loses its size information. So even though we know how big the array is here, once we pass it to a function, we no longer know how big it is. And so this will not work because you don't know how big the array is anymore. It loses the array. Muya makes another good point, which is that arrays are stack allocated. Vectors are heap allocated. Okay. So this is going to come off the stack, and if I make size big enough, let's make it 100 million elements. Right, we can't do this. Then it core dumps. It has appeared as a limitation on the new category on for loop. What about a while loop? Nope. It is not a limitation on the range-based for loop. It is a problem with pointer decay. So if you ever pass an array to a function, it turns into a raw pointer. And so a raw pointer, again, is just a memory address. But it's a memory address without a size. Here, we know what the size is. When we're in the scope of main, we know how big R is. And so you can actually call begin and end on R, and the C++ language actually will handle it. It will actually work right. Range-based for loops will work right because they know how big the array is. Once you pass an array to a function, a C-style array to a function, it decays into a pointer and you lose your size information. You don't know how big it is. So you can't print this with a while loop either because you don't know how many to print. Right? How many elements should I print? I don't know. I know where the beginning is, I don't know where the end is. And so this is a premier example of why you should never, ever use this. Ever. Period. Okay? If you do want a stack allocated constant sized array, for speed reasons, there is another, as they said at the end of episode 5 of Star Wars. There is another. Okay? Could you pass the size in as a second function parameter? Yeah, and that's what people do in C world. In the C world, they will pass in a size like that, but the range-based for loop still doesn't work. And you can't use sort, begin, and none of these things will work with it because you can't, because this is just a variable. It doesn't know that it's supposed to be the size. So let me show you the better way. C world, C, well, the letter C. The better way is by using a C++ style array, that one right there. So we have learned queues, we've learned stacks, we've learned vectors. Now we're going to learn arrays, but properly. Okay. So rather than using a C-style array, which, yeah, basically never use it. It's my advice. Just never use it. Rather than doing this, what you want to do is say array r size. Never use this. So there's a lot of things in the C++ language like that support C-style arrays. Don't use them. Period. Don't use them. Don't use them. Don't use them. Use an array. Okay. It doesn't suffer from array decay. So if you array what was it? What is this? Array int. There we go. It's an easy way of doing that. Array int size r equals 0. Yes, so this line of code here does the exact same thing as this. It's stack allocated. It can't grow or shrink. It's fixed size. It's faster than a vector, technically, if you care about that. Which, again, at this level, probably is not worth worrying about. But the range-based for loop is useful if you're going to iterate across an entire data structure. If you're not going to iterate across an entire data structure, you either use a regular for loop or you use a range using iterators. So don't ever rewrite this code. If you for whatever reason decide you really do need an array, then do it like this. There is something called the array class. And you know what the array class has? It has size information. So when you pass it to a function like this, you can see out array.size. Yay! Look at that. It actually includes the size information with it. Cool. And it's not even a function call. It's actually baked into the type itself, and so it doesn't actually take up any room to hold the size. It's actually determinable at compile time. So at compile time, we know how big it is. It's 100 million. Now this is still going to segfault because it's stack allocated. So if we do that and that, it'll still segfault because it's coming off the stack. Again, don't make big arrays off the stack, but if you're going to have a small array, then that's the way to go. Okay. So here's our array. Here's the array sorted. No, it's not sorted. What happened here? Oh, I deleted the sort line. That's why. And look, you can call array.begin and array.end. Look at that. That actually, those exist. The iterators exist. The ranges exist. You can use the C++ style. You can use a C++ style array with all of your favorite standard library functions. You can still do it this way if you want, using the global function, because the global functions are smart. And they will work with C style arrays or C++ style arrays or vectors, anything really. You can do this way, but in general, we prefer to write them like this. And yeah. So the C++ style array is just 9,000 times better than the C style array. Does not suffer from pointer decay. Okay. Once you decay to a pointer, you lose size information, and you lose the ability to do a lot of things in the language like this, which just turn off once it decays to a pointer. As long as it's still an array, you can do this, but if you ever sneeze on it funny, then it turns into a pointer, and you can't do this kind of stuff with it anymore. Okay. You guys want to learn you want to learn Deques now? I'm warning you, they're pretty complicated. Deques. They're like vectors with two more functions. Is pair considered a 2D array? A pair, yeah, we can learn the pair class too if you want. Have you ever had to use C-style arrays in the workforce? Of course. Yeah, C-style arrays are used everywhere. They just shouldn't be. Right? Like, you know, it's you know, when was C++ array used? So the generate function, did you guys get the generate function? I don't know if I explained that well enough. Kind of talked about it briefly. Basically with the generate function, or maybe that was when the audio cut out, you pass in a iterator to the range, at the beginning of the range, an iterator to the end of the range. So you select which part of the data structure you're going to be doing an operation on, in this case the entire thing, and it will set the element, each element of that range, to be the result of the function rando. Rando Clarician, of course. You know, also from episode 5. Okay. So yeah, so you can use this to generate a random array. It's faster than using a for loop. I don't know. Yeah, runtime faster, probably, maybe, because if the C++ language decides it can parallelize this, then you could actually, without having to type anything, you could just get parallel performance out of it. So, in general, it's a good idea to use standard library functions to indicate your intent. What we're going to do here is we're going to set every element of the array to be the output of rando. And then the optimizer now knows, okay, that's what we're doing. We got 4 CPUs on the system. CPU 1, you get the first quarter of the array. CPU 2, you get the next quarter. CPU 3, CPU 4, go. And it'll just run fast. Okay. Generate takes in a function pointer. Yeah. That was the mistake I made, right? I'm used to just typing functions like this, right? So without thinking about it, what it was doing was saying, for each element in the array, call the function at memory address, something. Because this is a random memory address. And this is very dangerous. And this is why I don't think they should allow casting from integers to pointers, honestly. So you need to actually pass in the function as the parameter. It's like with sort. With sort, you can pass in a function as a parameter, as the third parameter, and it will use that function to sort the array. Okay, so okay, yeah. So yeah, don't use that. People use this due to inertia. People will use the C-style arrays for no particularly good reason. Either they that's where I was going. Array. Either they don't know about the C++ array class, which was C++ 11, I guess. Is that when it was added? Okay. So yeah, there's a huge amount of people that are 10 years out of date. So they learned C++ in the 80s and 90s and are still coding the same way to this day. It is an old head thing, yeah. Right below, he has generate vec begin, vec end, rando. Yeah, that's correct. If I were to put parentheses here, it would call the rando function, and the result of that function would be a number, and that number would get passed to generate as the function to call. And so whatever function is at memory address 90 would get called. And that memory address 90 is within the minefield of doom, and it would segfault. So if I called rando, this would compile. It shouldn't compile. You're upset about IO stream? Good. Yeah, it did not compile. Good on you, C++. Don't do that. If it did compile, it would segfault, because it would be using an integer as a function address, which you should not do. When you're maintaining code before C++ 11, you still have to do C style. If you are at a company that has not updated to C++ 11, you must know this. Yes, absolutely. So you still have to know it, but yeah. You still have to know it. And yeah, it's the thing. And some companies have made the conscious decision not to upgrade to C++ 11 because something about the upgrade process would break their code. And so they're just permanently in ANSI C++, C++ 98. And that's their decision. It's fine. Okay. So, I still have to teach it, but in my class, I I don't think you should ever write code like this. The array class is just better. It's just better. It has size information with it. It has iterators. I believe it has r.at. Yeah, it can do bounds checking. Hey, look at that, bounds checking on an array. If we try accessing array.at -10, then it quits. Awesome, right? Who would have thought bounds checking on an array? It's an amazing thing. Okay, so difference between a C-style array. Okay, so let's learn about, what do you guys want to do next? Pairs or Deques? Pairs or Deques? Pairs. All right, cool. Pairs in utility, I think. It's in like some weird. It's in some weird header. C++ pair class. Or maybe tuple is in utility. No, not. Why does it always use C++.com minus stupid CPU reference? Thank you. It is in utility, yeah. And then is tuple in utility also? No. Where's tuple? I sometimes put these classes into weird header files. Why is parent utility? I don't know. That's also in tuple. All right, cool. But it's part of the utilities library. Okay. All right. Yeah. Cool. Cool times. Cool, super neat times right there. All right. There's probably a reason for it. I don't know. All right. So if you want a pair class that is in utility. All right. So what is a pair? A pair is two variables. That's all it is. So you can say pair of int and float named Bob equals 3, -0.000 -0.0. Okay. In what scenario would the old code break from updating to C++ 11? What if you had a function that they added a function for? What if you had a class like the array class that is named the same thing as the C++ array class, and you're using namespace standard, and so when they add things to the standard, it won't compile due to ambiguity things. And if you've got a million lines of code, odds are decent that you're gonna run into a problem when you upgrade standard versions, especially if you're not doing it right. Like that's, the reason why not to use namespace standard, right? If you have a large code base, you probably want all of your code wrapped in your own namespace, right? Namespace Kearney. Like that. Sorry. Like that. And then rather than calling it rando, it's now going to be called Kearney : rando. Kearney : rando. You guys see that? So a namespace is just a scope that has a name on it. And so basically all of the stuff inside of the scope here, print array, rando, all of these things now are no longer in the global namespace. They don't pollute the global namespace. A big part of modern C++ is keeping things out of the global namespace, because if every header file you use, the standard library, all of your code, if everything uses the same global namespace, you can only have that name once, right? And so it'll cause conflicts. It'll cause namespace conflicts. If I have a function called rando and I use a header file that also has a function called rando in the global namespace, congratulations, my code won't compile now, assuming that they have the same signature. Right? So when we use namespace standard and make function, okay, so when we were using namespace std and make function, we were making a function in the standard namespace. No, we are not adding to the standard namespace. We are adding to the global namespace. So when we do not use namespace Kearney like this, all of these things would be added to the global namespace, which is to say, just the not in a namespace. When you're using namespace std, what happens is when you type in a symbol name, like if I type in generate, so when I'm making a function call here to generate, what happens is the compiler is like, oh, he's trying to call a function called generate. Have I ever heard of such a person? And it will check the global namespace, and nope, doesn't exist there. And so it checks to see which namespaces we've included. We have included namespace std, so then it will then go through the standard namespace and look for a function name called std : generate. And it will find it. Okay. So this is the same thing as if I had written this, std : generate. And so when you say using namespace std, what it will do is it will try guessing if generate is part of std. Oh, look, it is. All right, cool, it works. Is pair library utility? Yeah. For better or worse, you have to hashtag include utility to get a pair. And so a pair is just, it's just two variables. It's templated, so they can be any two types. You can have a pair that has string so it's a string and a float. If you ever want two variables returned from a function, this is pretty common. So if we want to like return two integers from a function, you can do so by returning a pair of int rando2 return rand modulus 10 rand modulus 100. I don't know what I'm doing here. So this will return a pair. So it's using curly boys to construct an anonymous pair that gets returned. And so the first int is going to have, it's going to be a number from 0 to 9. The second integer will be a number from 0 to 99. And so this is, we use pairs a lot when you need to return two things. So if you want to return two values from a function, you could do like a call by reference parameter, but a lot of people prefer using a pair instead. Make pair. Getting hungry for pears now. Pears on a salad. Some sliced pears, gorgonzola cheese. Balsamic vinaigrette. Some brie. Yeah. Some walnuts. I don't know. Used in database primary key and record. Yeah, it's pretty common, right? Anytime you return two things. If you use the map standard library as a map class, it'll return two things. It'll return the key and value pair. So it returns a pair. Pretty common. I shall give you this pair. Yeah. Okay. So there is a more broader version of pair called tuple. So tuple sounds like, I don't know what it sounds like. Sounds kind of dorky, huh? Like tuple. Like Tupelo. Where is Tupelo? Is that South Carolina or Mississippi? Where's Tupelo? Mississippi? Yeah. Birthplace of Elvis Presley. Okay. Is there a difference between C++ and Python tuples? Yeah, I guess. I mean, Python's a different language, and so it's dynamically typed and all that kind of stuff. But the idea is the same, right? Which is that a tuple is it's like a pair but bigger, right? So a pair is two variables. If you need more than two variables in one variable, then you just be like a tuple. A tuple is a n-way variable. So you can say tuple int float string bool Sydney equals, what did I get myself to? -10, comma 1.1, comma 0.001, comma Sydney. What's a good last name for a Sydney? Escobar. And true. Okay. So, okay. Oh, how do you access these elements, by the way? So it's like you're making a struct without having to make a struct. Do you guys see that? So like rather than having to declare a struct class for like a Pokemon and then do all this kind of stuff, you just be like, it's a tuple, and it just makes a struct kind of for you. But like, how do you get at these elements, right? Like, how do I print hi? So I'd see out bob.first. That would print hi. What do you guys think the second element of Bob is called? Struct is in the tuple. The tuple class makes a struct for you, kind of, if you want to think of it that way. Second. Yep. So it prints out hi, and it prints out -00032. So this is pretty common though if you have a function that wants to return 2 values, and so you just return a pair. And then if you want to return 3 values or 4 values or 5 values, you use a tuple. Okay. So let's return a tuple of int called return 1, 2, 3, and it's going to return 1, 2, 3. It's very exciting. It's a super exciting function. Okay. So then I could say tuple int Wendy is equal to printing namespace : return 1, 2, 3. So you guys see that? What did I type wrong? It doesn't like Wendy. No viable conversion from tuple int to tuple int. What did I do wrong here? Make the function call. There we go. All right, there we go. So why are first and second public variables as opposed to getters and setters? Because pair is designed to be a pods, Mr. Wolf. It's literally designed to be just 2 variables. It's like if you want to return 2 variables, it's 2 variables. It's plain old data. It's just here's 2 variables. There's no nothing crazy about it. Okay. It's literally just glue. So sometimes you need to pass 2 elements in or get 2 elements out, and so it'll take a pair and return a pair. And it's 2 variables living under one roof. It's one step above a primitive. Yeah, it's literally, and it's deliberately plain old data for a reason, because you don't have to worry about copy constructors and all that other stuff. It's 2 variables. How to print tuples? Great question. So we've got Wendy here, and Wendy is going to be set to 1, 2, 3, right? So Wendy is 3 integers under one roof. The first integer is going to be set to 1, second to 2, third to 3. So how do we print those? First, second, third? I don't know if that would work. Would that work? I don't think that would work. I think you have to use array indices. Tuple C++. C++.com. Why do you do that? Yeah. I don't see first, second, or third on there. Yeah. So you use get. Okay. So get is the way that you get elements out of a tuple. So you get 0, and that'll get 1, that kind of stuff. Okay. You get it now? So cout get element 0 from Wendy. get element 1 from Wendy, get element 2 from Wendy. There you can see 1, 2, 3. What other structure uses that get function? You get it now. What other structure uses get? I don't know, it's probably tuple. Yeah, you don't need to do that anymore. There's structured bindings now. It's kind of cool. So let me show you a cooler way of doing that. So use auto and square brackets, and this is pretty cool stuff. Let me show you an example of it. Yeah, this works ever since C++ 17, and let me show you what that looks like. Why not learn a map then, or better, a collection? We'll do. We're not doing maps today. We're gonna get to Deques today though. Okay, so rather than doing this and this, which is kind of annoying, it's kind of annoying. Let's be honest, it's kind of annoying. What I can do is I can say, was it auto square bracket? I need variable names now. Hardest part of computer science. 1, 2, 3 equals Kearney. Return 1, 2, 3. So, okay, so what have we learned today? We've learned a pair is 2 variables under one roof. We've learned a tuple is n variables under one roof. Structured bindings since C++ 17 and above allow you to bypass tuples entirely. Mostly. They allow you to bypass tuples. So what does this do? This makes a variable named 1 and sets it to the first value returned from return 1, 2, 3. Ditto for 2, ditto for 3. Okay, and so what this will do, this is actually going to make 3 variables. And it unpacks the tuple and then assigns the parts of get 0 gets assigned to 1, and so on and so forth. So we can just see out 1, and then ramen emoji, followed by 2, followed by space emoji, followed by 3. Okay, and so this is actually creating 3 variables. It's creating 3 variables, and when you're returning a tuple, it'll grab the first part of the tuple and stuff it into 1, and the second part of the tuple and stuff it into 2, and the third part of the tuple and stuff it into 3. And the best part is you don't need to know what the types are. So if I came up here and changed return 1, 2, 3 to return int string, then this would break, right? Because I had to define what Wendy was, right? But this code here actually works just fine. 3's type will change to be string. And so probably what I should have done here, rather than writing this ungodly thing out, I probably should have just used auto, right? If you use auto, then it deduces the type of Wendy from the function. Is that not working? No viable conversion from that to that. Yeah, it works fine. I don't know what COC is complaining about. Works fine. Yeah, and so rather than writing long type names out, oftentimes it's preferable to write auto, because then it will deduce the type of Wendy from the return value here. And so so if I ever change the return type here to be string, then Wendy turns into a tuple of int string, and down here 3 just becomes a string. It's just a regular string. And you can see that Windy is printing out 1, 2, 3 now, rather than the number 3. And the structured bindings is printing out 1, ramen, 2, spaceship, 3. Red fish, blue fish, you know. Pretty cool stuff, huh, guys? Not super like, I don't know. It's called utility for a reason. Like, they're just kind of, they're kind of there. They're kind of useful, I guess, but it's not going to blow your socks off, you know. Could you do auto 1, 2? Good question. If you don't catch something, looks like it. Oh, it's not going to compile. So I'm printing 3. Look at that compile speed. The thing is chugging. Pata, you killed my compiler. Something's eating at my CPU. Huh. COC is actually eating at my thing. Alright. Kill. Die. Interesting. Yeah, COC went out of control. Alright. G++ main.cc. Yeah, you can't do that. Okay. Yeah, htop. If you type htop, that will bring up the task manager essentially for Linux. C matrix. Alapisco is staring at the matrix right now. Okay, so those were some minor classes that I guess is useful. Yeah, sure, it's useful, I guess. If you ever need to return multiple things from a function, there you go. And if you ever have a function that gets multiple results, using structured bindings is really nice. That way you don't have to go through this weird syntax. That's why I had to look it up, by the way, because I very rarely actually need to do that. Pairs are mostly what I use, and if I do need a tuple, I typically these days use structured bindings instead. Okay, so let's get into Deques. Okay, so we've got, today we went over arrays. Never use this. Instead use this. C++ arrays are entirely better than C style arrays. There's literally no reason to use a C. Literally no reason to use a C style array. Unless, as he said, you're not in a modern environment. If you transfer to a university that does not allow modern C++, then yeah, okay, cool. Sucks to be you. Arrays, vectors, pairs, tuples, now Deques. Yes. All right. Although you guys should have known vectors already. Also, the first and second part of the pairs will have the same variable throughout the map. First degree difference. Yeah, okay. All right. So let's talk about Deques. So let's do this. DEQUE, deck of ints, named deck, of size, makes 100 ints, all initialized to 0. If you guys are looking at this and saying that, wow, that looks a lot like a vector. Yep. Yep. In fact, if we, let's comment this out for a second. If I was just to change the type of a vector to be a deck, would you notice any difference when it ran? Probably not. It's all the same. So, at any point, you can just be like, I want a deck now, and just change the word vector to deck, and then everything magically works. Even though what is happening behind the surface is completely different. A deck is like a linked list of arrays, if you want to think of it that way. So you guys know how fun it was to write your own linked list with pointers and all this kind of stuff. Beneath the surface, Deques are very different from a vector, but you don't know that. It's not, that's why we have this notion of an abstract data type. From a distance, from the interface, you have no idea what's actually happening underneath the hood, and that's by design. You don't know how it is. Is it a linked list? Is it an array? Who knows? How is it implemented? Who knows? It doesn't matter. All that matters is that the interface for a Deque is identical to that of a vector with the addition of two functions. What about an array of linked lists? Sure. Yeah, who knows? We don't know. I mean, I could probably look it up, but locate q.h. Jeez, there's a lot of them. Never mind. We're not going to look it up. Maybe we'll look it up. No. Where would you be? No. Whatever. I'm not going to look it up. All right. So the point is that if you're really curious, you can look it up and see how it's implemented. I'm usually not curious about it because it works. It works. So yeah, look at that. I just switched out vector to be Deque and everything magically worked. And that is the beauty and the really awesome, well done job and I'm not being sarcastic here for once. I'm actually being serious. The well done on the C++ standards committee part. A lot of these standard container classes are interchangeable with each other, right? And so if you want to just try it out and see what the performance difference is, if you move from a vector to a Deque, you just change one word, and then all of your code will just become a Deque. And beneath the scenes, all this stuff changes, right? It's using linked lists and pointers, and all this stuff's happening. And to you, the user of it, you don't have to know any of it. I just changed one word, and all my code changed. Okay. So what is the difference between a vector and a Deque? Great question. So a Deque is a vector that you can push front and pop front. That's the difference. Order one. Okay. So a Deque is a vector that, in addition to push back and pop back, you can push front and pop front, and those are order one operations. Okay, with a vector, if you insert it at the front, it's order n. If you delete it off the front, it's order n. Why? Because if you delete off the front of a vector, then it has to shuffle all of the elements forward one space. So if you delete off the beginning of a vector, that's an order n operation. If you have 1,000,000 elements in your vector and you delete the first element, it has to do 1,000,000 operations. Okay. For a Deque, if you delete off the first element of a Deque, it's order one. Constant running time. Okay. That's it. That's it. That's all you have to know about a Deque. Yeah, the skeleton of a Deque is a linked list, maybe. Who knows? There's a couple different ways you can implement it. So, there's an obvious question here. Nobody's asked yet. What is the obvious question? Does it have order one index access? Kind of. Why is it always C++? Why not use a Deque? That's the obvious question. Thank you very much. Yeah, well, if it's better than a vector, why use a Deque? Why does everybody use a vector? And the answer is because when I've benchmarked it, vectors are 20% faster. That's the answer. So if you do not need pop front and pop back, use a vector. If you need them, use a Deque. You guys got it? That's the lesson for today. Thanks for coming to my TED Talk. Have a great weekend. order1.at. Yep. So it's better than a linked list. Constant running time. You can randomly access elements out of the linked list. Out of the deck. You can't do that. You cannot do this. You can't do that with a linked list. With a linked list, you have to iterate across the linked list. Right? So another obvious question is, why would you use a linked list? A linked list, you can insert elements in the middle in order one time. So if you have a pointer to somewhere in the middle of the linked list and you call insert, it can go in order one time, right? Because you just do a little couple pointer games, and then it's inserted. With a deck, if you insert in the middle, it's order in. So you can probably create some sort of table of like when you should use something. In fact, I can make that for you guys right now. When should you use the different data structures? And if you want to know what you're supposed to get out of this class, it's this. Okay? There's really two really important things you need to walk away with from this class, in addition to just getting better at programming and, you know, getting more experience into your belt writing programs and stuff like that. There's two things you guys have to walk away from this class with. One of them is Big O, because Big O is used everywhere. Like on that website, complexity, constant running time. You have to know what that means, or you will be a terrible computer scientist. If you write an order n algorithm when it could be order one, if you write an order n squared algorithm when it could be order n, you're a bad computer scientist. So one is Big O. The other is, when should I use this data structure? Given this task, what data structure do I need? Do you guys understand? And there's no right answer. There's a number of answers, and that's why you have to take this class. That's why literally every computer science program in the nation has data structures as the class following CSI 40, right? Because there's a lot of data structures. Some of them are good at some things and bad at other things, and some other ones are good at those things that are bad at the other things, right? And so what you need to walk away from this class with is a mental table of like, okay, I need this, this, and this to be fast, and I don't care about these being fast. Oh, I should be using a deck. Oh, I should be using a map. Oh, I should be using a stack. Oh, I should be using a linked list. That is the key takeaway point. Because are you going to write your own linked list? Maybe. I've done it. Not often. I normally use the standard library. You know what I mean? It's faster. So here is the what are the limitations of Deques? Yeah, they're slow. They're slower than vectors in general. So let me just type up a thing called data structures when.text. Okay. So linked list. Okay, here. Let's do it simple. Pair tuple when you need glue between two things, then one variable. Okay, so if you're going to return two things from a function, use a pair. If you're going to return three things, use a tuple. Easy. We shall talk about it no more. Okay, stack. When to use a stack? When you need a LIFO, last in, first out model of X and data. In reality, just use a vector. Q. When you need a FIFO model of accessing data. In reality, use a list or deck. Okay. Like you could call your vector a stack, and people will understand what's happening. Right? Like if you go vector of ints named stack, like people will know exactly what you're doing here, right? You don't have to make a stack of integers. Right? So the Q class and the stack class, you have to know what they are conceptually, but in reality, we just use vectors and lists instead. Okay. What about time difference between a stack and a vector? A stack class literally uses the vector class underneath, I believe. And so there's literally no difference. The stack standard library stack class, and it gets an ADT. I actually don't know how they implement it. You're not supposed to know, but in reality, I believe they use a vector. The stack class in reality is just a vector with functionality disabled. Just use a vector. Because a vector, you can just print all the contents of it, things like that. Okay. For Q, just use a list. Thank you. Double-ended Q. Okay. Thank you. Because the Q class is just a list for deck with functionality disabled as well. So those two, you need to know what they are, and you need to know what a stack is, and you have to know what a queue is. And in reality, though, you'll never find me hashtag including stack. Okay. All right. So vector, vanilla ice cream.
How is that
Hmm? This is college stuff, girl. You wouldn't understand it. It's highly advanced. Highly advanced computer science. So, what is vanilla ice cream used for?
Vanilla ice cream is used for getting into your tummy.
It's used for eating. Yeah, but I mean in like a culinary sense. You know, when you're making desserts, when do you use vanilla ice cream?
When you just open an ice cream store.
When you open an ice cream store. That's an interesting take. Okay.
Or actually, when you're putting in new flavors of ice cream.
Okay, all right. You don't understand vanilla? Vanilla, you know, is actually one of the most expensive.
Yeah.
It's one of the most expensive spices on the planet, and so vanilla. So people treat vanilla ice cream as if it was like cheap, you know, or like sort of like flavorless, or like boring. But vanilla is actually pound for pound, like enormously expensive. Like, how much is a pound of it?
It can be like worth gold. It's like you're holding gold.
How much is a pound of real vanilla? How much would that cost? Buy vanilla beans, not.
I mean, vanilla beans is real vanilla, Dad.
Yeah. Prices for vanilla hover around $300 per pound. Yeah. So natural vanilla is $300 a pound. So it is not cheap. Yeah. So like saffron, I think, is probably more expensive than vanilla, but it is not cheap. The reason why vanilla ice cream is so widespread is because it's very versatile and it's very useful, right? So when I call vectors vanilla ice cream, I don't mean that it's bad. I just mean that it is ubiquitous, and versatile, versatile, found everywhere. Okay. And so when I need to store lots of data, I start with a vector. That's it. I'll start with a vector. And if I discover I need to insert in the middle or beginning, then I switch out. Okay. A lot of times, though, I don't. Okay, list. What is the benefit of a list? List has fast, and so vectors are, what are they fast at? They're fast at inserting at the end and deleting it in. They can grow over time. That's nice. They're heap allocated. Pretty much all these data structures are going to be heap allocated. All are heap allocated. Do you guys understand what I mean by heap allocated? Like they're made through using new, not on the stack. All are heap allocated, set array. And so if you need a large array, you're probably going to Stack Overflow. You're probably going to crash your program. Because there's only like 100 megs of stack space, something like that. So if you need more than 100 megs of RAM, make sure you use, I think pairs and tuples are stack allocated. I think those are stack allocated too. Easy access, push pop, sort for vectors. Does sort work with pairs? No. No, you can't sort a pair, I don't think. I don't think they begin and end vectors.
Wait, you can't?
No begin.
You can't sort a pair?
No iterators.
You can't sort a pair.
Just do it yourself. Just flip them if they're out of order.
You can't sort them. It's like they don't have their own thing. It's like it cannot be sorted into different groups.
So all those range-based algorithms like sort, generate, random shuffle, all those things, none of them work on a pair and a tuple. A tuple is not really a data structure. It's a really trivial data structure, right? It's just a bunch of variables. It's not really organized in any particular way. So yeah, good question. Can you go over the heap versus the stack? Yes. So how much time do we have left? 2 minutes. Then no. The heap heap allocation is from new. Stack allocation is regular variables. Pointer r equals new. Okay. And so heap allocation is permanent. It lasts until you delete. Stack allocation, it deletes it automatically for you. The heap can be much bigger than the stack. Usually is. Okay. So list is fast. Inserts basically everywhere. Basically anywhere you have a pointer to it. Slow overall. Lists are not fast overall. Deq. When do you use a deq? All right. So deq. Use a deq when you want a vector. You can push and pop off the front. If you don't need that, use a vector, since vectors are 20% faster. There, that's Deques. That's our data structure for today. So they're vectors that have push front, pop front.
That does not look like a percent symbol.
It's a percent symbol, 20%.
Kind of looks like it.
Okay, enqueue and deq. Enqueue is an operation, so you enqueue something by adding it to a queue. That's what you're talking about. Are you pushing out this text? Yeah, of course. I'll put it up in public. Okay. So bag, bag. Yeah. That's a mental model they use for collections. It's not a real data structure. Although I guess you can make it. Okay. So lists, use lists when you need to be able to order one insert anywhere you have a pointer. That's it. Not often. You don't use lists nearly that often. Oh, also splicing is combining two lists with splice is order one. Here. Class bag. Yeah, they always use that in like textbooks. The bag class. Okay. Out of all the structures found here in the future, what is not found in C style? None of these are in C. None of these are in C. Yeah. The C language doesn't come with any of these. All of these are part of the C++ standard library. All you get in C, the only default data structure in C is the array, C arrays. And everything else you have to make yourself. C style arrays, don't use. Yeah, that's easy. C++ style arrays, use if you need speed over a vector. Otherwise, ignore. Honestly. Okay. Is sort vector big O-N? No. Sorting is sorting is always in login. Sorting is always in login. There is no such thing as an order in sort unless you have special cases like radix sort or something like that. By making yourself meaning is not pre-made in the library. Correct. The C language does not come with a standard library that C++ has. You cannot just hashtag include list. You cannot hashtag include vector. Vectors don't exist in C. You have to make it yourself. Yeah. Or find somebody that's done copy and paste it. Yeah. The only thing that comes with the C language is C-style arrays. And C-style strings, which are also a form of array. Yeah, go call your friend. Okay. So that's it for today, guys. I will put this up in public. Hopefully this is not too complicated for you. Deques are vectors that you can push and pop off the front. Order one time. Okay. So, yeah, nothing too crazy. So I will put this up. This will be copied, and I'll just move data structures when into public. So if you guys want to copy that, it is /public/data structures when. And that's a summary. That's a summary of all the data structures we've learned so far. Okay. And that's what you should come away from this class with. It's that table memorized. Yep. Are you able to see all the items in public? Yep, that's why it's called public. So when I type CHP, that is an alias that I have that makes everything in the public directory to be public. It's faster than chmod everybody may read /public/data structures when. Rather than having to type that out, I just have an alias that just literally makes the entire directory structure public. It's inefficient, but it's faster for me to type, and so I'm optimizing my time, not the computer's time. All right, thanks guys.